Hello and welcome to this session of ratio and proportion. We will be doing the sixth sum, 3x minus 4 cube minus x plus 1 the whole cube upon 3x minus 4 cube plus x plus 1 cube, which is equal to 61 upon 189. If you look at this sum, you see here componendo and dividendo is already done over here. If further we want to use componendo and dividendo to do, what can be done in this sum? Can we take this here? Can we take this here so that to find the value, can we use componendo and dividendo later on? So to use this, first step in this is let us use invitendo. So using invitendo, So using invitendo, what we will be getting is we will just invert it. Now to invert this, let us take this 3x minus 4 cube plus x plus 1 cube upon 3x minus 4 cube minus x plus 1 the whole cube, which is equal to, now what we did on the left hand side, same thing has to be done on the right hand side. So 189 upon 61. When we get this, now look at this carefully. What can be done to this? As we had decided to first invitendo, right? And now can we use componendo and dividendo so that we can get the value? So let us use componendo and dividendo. So using componendo dividendo, so when we are using componendo and dividendo, let us see what care has to be taken over here. Let us first use componendo. We'll put a bracket. Okay. After putting the bracket, we'll take this 3x minus 4 cube plus x plus 1 cube. Okay. Now what we are using? Componendo and dividendo. So plus, we'll take this. Okay. 3x minus 4 cube minus x plus 1 cube. Okay, upon, now what will come over here? 3x minus 4 cube plus x plus 1 cube, and we have using componendo and dividendo here, so I'll get here minus 3x minus 4 cube minus x plus 1 cube. Okay, but here we have to do, which is equal to 189 plus 61 upon 189 minus 61. Now what is our next step in doing this? We have to open this brackets. Now while opening this brackets, we have to take care of the signs over here. We have to take care of the signs. So let us open the bracket step by step and see. Therefore what we will be getting is 3x minus 4 cube plus x plus 1 cube. Okay, plus, and what is the sign? Plus over here, so we get plus 3x minus 4 cube, plus into minus gives me minus x plus 1 cube upon. Let us open this bracket and see what do we get. 3x minus 4 cube plus x plus 1 cube. Now minus into plus gives me minus 3x minus 4 cube. Minus into minus will give me what? Plus x plus 1 cube, which is equal to, now 189 plus 61, 9 and 1 10, say 8, 9, 15, 1 plus 1 2, that gives me 250 upon, if I take away 189 from 189, if I take away 61, how much I'm going to get is 128. Now look at this. What can be done further? This, you have got x plus 1 cube here, you have got x plus 1 cube here, you have 3x minus 4 cube here, 3x minus 4 cube here. But if you look at this, here you have got plus x plus 1 cube, here you have got minus. Can I get rid of this? Yeah. Okay, this and this goes away. Here I've got 3x minus 4 cube, here I've got 3x minus 4 cube, here I've got x plus 1 cube, here I've got x plus 1 cube. Here, can I get rid of anything here? Yeah, this and this. So therefore what do I get? What I am getting is, see, 3x minus 4 cube and 3x minus 4 cube. There are two i's. 1 plus 1 gives me how much? 2. 3x minus 4 cube upon x plus 1 cube and x plus 1 cube. What I have is twice x plus 1 cube, which is equal to, what do I get here? If I reduce, can I reduce it further? So I got this, can I reduce it further? When I reduce this further, I get, suppose I use 2 6s are 12, 2 4s are 8, then 2 1s are 2, 2 2s are 4, 2 5s are 10. Let us use 2 1s are 2, 2 2s are 4, carry 1, 2 5s are 10, 2 6s are 12, 2 4s are 8. So what I get is 125 upon 64. Now here if you see, what can be done over here? Can I cancel this? 2 1s are 2 1s are. Therefore, what do I get? I get is 3x minus 4 cube and x plus 1 cube, which is equal to. So, therefore, I get 3x minus 4 cube upon x plus 1 cube, which is equal to 125 upon 64. Now carefully look at this. What can be done here? Can we do anything here so that we can get this value? If you look here, you have got cube here, you have got cube here. Can I take cube roots of this? Yeah. So if I taking cube roots on both sides, taking cube roots on both sides, what I will be getting is 3x minus 4 upon x plus 1 is equal to, now 125, whose cube root is 125? 5 5s are 25, 25 5s are gives me 125, so I've got 5 here. And whose cube root gives me 64? 4. So to get this, now what we are going to do? Can we use cross multiplication over here? Yeah, we can use cross multiplication. 4 into 3x minus 4 is equal to 5 into x plus 1. Now what is the next step here? Therefore 4 3s gives me 12x minus 4 gives me 16, which is equal to 5 into x gives me 5x plus 5. Now what can be done here? I've got 12x and 5x. Therefore, can I get this 12x? Can I bring this 5x here? If I get this 5x, it is plus 5x. If I get here, what do I get? Minus 5x. 5. If I get this minus 16 on this side, it becomes plus 16. So, therefore, what do I get? I get 12x plus 12x minus 5x. It gives me 7x. Okay? So 7x it gives me, therefore 7x is equal to 5 plus 16 gives me how much? 21. So 7x is equal to 21. Therefore, x is equal to 21 upon 7. Now, can I reduce it? 7 1s are 7, 7 3s are 21. Therefore, what do I get the value of x as? 3 upon 1 is 3. So, in this way, we saw how to invert it and how did we solve that value of invitendo. Let's move on to the next one. Theorem on equal ratios. If A upon B is equal to C upon D, then A upon B is equal to A plus C upon B plus D, which is equal to C upon D. This is the theorem on equal ratios. So to study this theorem on equal ratios, let us take a fraction, ratio of certain fraction. Now if I take 2 upon 4 is equal to 3 upon 6, which is equal to 4 upon 8. Look at this fraction. Look at 2 upon 4, 3 upon 6, 4 upon 8. Now let me reduce this. 2 1s are 2, 2 2s are 4. 3 1s are 3, 3 2s are 6. 4 1s are 4, 4 2s are 8. 2 1s are 2, 2 2s are 4. 3 1s are 3, 3 2s are 6. 4 1s are 4, 4 2s are 8. All of them are equal if you see, because they have got the same value of 1 upon 2. Now, if I add them, if I add them, let me see on adding what do I get. If I add this, what I will be getting is 2 plus 3 plus 4 upon what I have is 4 plus 6 plus 8, which is equal to 4 plus 3 is 7. 7 plus 2 gives me 9 upon 6 plus 4 is 10, and I get here is 18. Now, if you see here, if I reduce this, 9 ones are 9, 9 twos are 18. What do I get? I get 1 upon 2. Now, this we did it on adding. Let us do it on subtracting. On subtracting, what do we get? 2 minus 3 minus 4 upon 4 minus 6 minus 8, which is equal to, these two are negative, so we will add them. 4 plus 3 gives me 7, that is minus 7. Minus 7 plus 2 gives me minus 5. Okay, from this I get minus 2, 8 and 2 I get minus 10. So minus minus goes away, 5 ones are, 5 twos are 10. If you see, here also we are getting the ratio as 1 upon 2. All of them. So any operation you use, you get your original value, that is 1 upon 2. Original value, which is 1 upon 2. When we are getting our original value, if this total is equal to 1 upon 2, we get this original value back. That is called as a theorem on equal ratios. So let us see a few examples based on this ratio and proportion, and on that theorem on equal ratios. Fill in the blanks of the following. Now when you see this fill in the blanks of the following, we have got x upon 7 is equal to y upon 3, which is equal to 3x plus 5y, which is equal to 7x minus 9y. And if you look at this, we are going to use theorem on equal ratios. Here directly we can be doing this. We can do it directly. There is no problem over here. So what is given? Let us see first. So if I use here x upon 7 is equal to y upon 3, which is equal to. Now here I have got 3x. To get x is multiplied by 3. So what I do is I multiply this by 3 into x to get that 3x. Okay. I multiply this by 3. So I multiply this by 3. Okay. Which is equal to. Now what I have over here, I have got 5y. To get this y, I multiply this by 5. Okay. 5 into y upon, what do I have over here? I've got 3 over here. So I will multiply this 3 by 5. 5 into 3. What do I get? I get x upon 7 is equal to y upon 3, which is equal to. Now 3 into x gives me 3x upon 7 into 3 gives me 21, which is equal to 5 into y gives me 5y. 5 into 3 gives me 15. Now let me use by theorem of equal ratios. By theorem of equal ratios, what I am going to get is 3x plus 5y upon 21 plus 15, which is equal to 3x plus 5y upon. Now 21 plus 15 gives me 36. That means what I will be getting is, see, I got 3x plus 5y. What I will be getting is 36. Yeah. Let us take the next one. What is given to us? Let us first see. X upon 7 is equal to y upon 3, which is equal to. Now, if you see here, the 7 is multiplied by x. So, I will multiply this x by 7. 7 into x upon what I have here. Similarly, I have to, when I'm multiplying this by 7, I have to multiply this also by 7. So, 7 into 7. Okay, which is equal to, now what I have here, 9 into y. That means this y is getting multiplied by 9. So 9 into y upon what I have here, 3. So 9 into 3, which is equal to, if you see, x upon 7 is equal to y upon 3, which is equal to 7x upon 49, which is equal to 9y upon 27. Now, by theorem of again equal ratios, by theorem of equal ratios, if it is for addition, it is also for subtractions. So 7x minus, we have just seen, okay, and we have got 49 minus, if you see, 49 minus 27. What does it give me? It gives me 7x minus 9y. 49 minus 27. What do I get by 49 minus 27? If I take away 27 from 49, I am getting is 22. Let me multiply and see that. Minus 49 minus 27, it gives me 22. So what I will be getting here is 22, and here I will be getting is as 36. As simple we are using. Let's move on to the next one and see. If a upon 3 is equal to b upon 4, which is equal to c upon 7, which is equal to a minus 2b plus 3c upon what? Which is equal to dash upon 6 minus 8 plus 14. As I said to you, what is given to us? Let us see that. We have with us is a upon 3 is equal to b upon 4, which is equal to c upon 7. Okay. Now, if you look here, we have a minus 2b and we have got plus 3c. Therefore, a upon 3 is equal to get here minus 2b, we are going to multiply it by minus 2. So, what would we get? Minus 2b. And if I multiply the numerator, what you did, the denominator also has to be done. So, I multiply this 4 by minus 2, what I get? Minus 8, which is equal to c. What I have? 3c. So, I have to multiply this numerator and denominator by plus 3. So, what I get is 3c upon 3 sevens gives me how much? 21. Therefore, by the theorem of equal ratios, by theorem of equal ratios, what we get is a minus 2b plus 3c upon 3 minus 8 plus 21. Now this is equal to a minus 2b plus 3c upon. Now you have got 3 plus 21 gives me 24. Out of that 24, when I remove this minus 8, how I'll be getting is, I will be getting is 16. I will be getting is 16. Okay, so we know that what value we are going to get is 16 over here. What about this? Look at this. We have 6 minus 8 plus 14 plus 14. What we have with us, let us see. A upon 3 is equal to B upon 4, which is equal to C upon 7. Therefore, now here we want 6. To get this into 6, we multiply this by what? 2. So similarly, what we are doing here, we have to do it over here. So what we get, multiply it by 2 to get this 6 over here. So we take this as 2 3s are 6. Similarly, you have to multiply this by 2, you get 2a, which is equal. What you require here, minus 8. So we multiply it by minus 2. What we get is minus 8. And similarly here, what we did here, we are going to do, we get minus 2b, which is equal to, we require here 14. So we have to multiply this by 2 to get the 14. And whatever we are doing here, same we have to do here. We have got to see. Now by theorem of equal ratios, by theorem of equal ratios, what we are getting is 2a minus 2b plus 2c upon 6 minus 8 plus 14. We need not do anything to this because we already have here. What we wanted is, we wanted this. So we can write 2a minus 2b plus 2c is equal to, or rather we can say 2a minus 2b plus 2c. Okay? Let's move on to the second one and see. 5m minus n is equal to 3m plus 4n. Then find the values of the following expressions. We have to find the value of expressions. As I always tell you, what is given to us, please see that what is given to us. It is given to us as 5m minus n is equal to 3m plus 4n. Now from this, we have to find m square plus n square. Is there any relation over here? Nothing. We cannot see anything. So what is given to us, from that we are going to do it. So let's start and see from this what is given to us. We have got, what we have with this is 5m minus n is equal to 3m plus 4n. This is given to me. Now what can be done to this so that I can get the ratio m is to n. When I get this ratio m upon n, then I can use componendo, dividendo, alternando, I can use, right, relations. So what is given to me is 5m minus n is equal to 3m plus 4n. So let us bring this 3m to this side. Therefore 5m, I bring this 3m to this side, so I get minus 3m, which is equal to, what I have here, 4n. I bring this n over here. When I bring this n over here, what it will become? It will become plus n. Therefore, what I have with me, 5m minus 3m, what it gives to me, 2m, which is equal to 4 plus 1 is what, 5n. Now you might be thinking, I'm solving this, where will I get this then? But what is given to me, I'm using that, and what I get after solving this, I will use the relations of the ratios which I know. So what I do here is, therefore, m, I bring this n over here, it becomes m upon n is equal to, I've got 5 here, I bring this 2 here. Now I've got m upon n. Now if you look here, what do I have? I have got a square term here, I've got a square term here. I'm getting a square term here. So what can I do? I've seen that I can square it. So squaring both sides, squaring both sides. When I square the both sides, what I get m square upon n square, which is equal to 5 square upon 2 square. Therefore, what I am getting is, if I square that term, what I am getting, m square upon n square is equal to, what does 5 square gives me? It gives me 25 upon, what does this should be, square? Square. So what does it gives me? It gives me 4. Now look here and look here. What we are having, n square upon n square is equal to 24. Now what can be done? See, you can see here we can use componendo and dividendo. So by using componendo dividendo, what I will be getting is m square plus n square upon m square minus n square is equal to 25 plus 4 upon 25 minus 4. Therefore, m square plus n square upon m square minus n square is equal to 25 plus 4 gives me 29, and this gives me 21. Can I reduce it further? No, I cannot reduce it further. So let's move to the next. 3m plus 4n upon 3m minus 4m is given to me. Okay, so let's start with the solution. We know already, if you see, we found this m upon n is equal to 5 upon 2. We are going to use the same thing in our next sum. So what we got is m upon n is equal to 5 upon 2. Now look at this. Directly I cannot use componendo and dividendo because I will get m plus n and I will get m minus n. But what I need is 3m I need here and I need 4n. So what can I do to get 3 here and 4 here? What should we do so that we can get 3m and 4n here? To get this, can we multiply by 3 upon 4 so that we get here 3m and here we get 4n? Okay, let's see. Multiplying both sides by 3 upon 4. Therefore, let us see what we get. So, 3 upon 4 into m upon n, which is equal to 3 upon 4 into 5 upon 2. So, what we will be getting? Therefore, 3m upon 4n, which is equal to 3 5s gives me 15 upon 4 2s gives me 8. Now, can I use here componendo and dividendo so that I can get this 3m plus 4n upon 3m minus 4n? Okay, let's see. By using componendo dash dividendo 3m plus 4n upon 3m minus 4n, which is equal to 15 plus 8 upon 15 minus 8. Therefore, we'll do it here. Therefore, 3m plus 4n upon 3m minus 4n, which is equal to, now 15 plus 8, what it gives me? 23. And 8 take away 15 gives me how much? 7. So we saw that if any ratio is given, m upon n is equal to 5 upon 2, which is equal to 5 upon 2, we found multiplying both sides by 3 upon 4 by this values, and we got 23 upon 7. So let's move on to our next slide. If a y plus z, which is equal to b z plus x, which is equal to c x plus y, and out of a, b, c, no two of them are equal, then show that y minus z upon a, b minus c is equal to z minus x, and b c minus a, which is equal to x minus y upon c a minus b. To get this, see, is there any relation? If you see here, here we have got ABC, here we ABC, here we have got y plus z, here we have got y minus z, here z plus x, z minus x. So let us first see what we have with us. Solution. What is given to me? A y plus z is equal to b z plus x, which is equal to c x plus y. This is given to me. Now to get this, to get the ABC here, ABC, because I need ABC down. So can I divide each ratio by ABC? So dividing each ratio by ABC. Let us divide each ratio by ABC. So we have a y plus z upon ABC, which is equal to b z plus x upon ABC, which is equal to C x plus y upon ABC. Now look here. We have got AY plus Z upon ABC. So this A gone. This B gone. This C gone. What do I get? Therefore, I get Y plus Z upon BC, which is equal to Z plus X upon AC, which is equal to X plus Y upon AB. Now I have got this. Let us use theorem on equal ratios. To get this theorem, what we need here, we need A, B, C here. So to do this, let us use theorem of equal ratios. By theorem on equal ratios, we get, what we will be getting is, let us see what we have over here. To get this y minus z, I want y minus z. If I use this to y plus z and I take this, and if I subtract this, what will happen from this? Y will go away and I will be getting z minus x, and this if I use, right, AB, and I take BC and I've got AB. In that, if I remove B common, I will be getting BC minus AC. Okay, so in this case, what I will be doing is, by theorem on equal ratios, y plus z minus x plus y let us do it by theorem on equal ratios. So what I have, x plus y, and I will be subtracting this from this to get this x plus y minus z plus x upon what I have here, AB minus AC, which is equal. Why I have subtracted this from this? As I have told you, why I have subtracted? So that I can get A, B minus C. Okay, let's open this bracket and see. X plus y minus z minus x upon AB minus AC, which is equal to, this is gone, this is gone. Okay, what I will be getting is y minus z upon, I remove common here, A, B minus C, which is equal to K. Let this be my equation number 1. Now let us take the other two. Here, now what I am going to do, similarly I am going to use theorem on equal ratios. So similarly, by theorem on equal ratios, by theory what we are going to get is, now if you take this line, what I am going to do is z plus x, and so what, this in the third, y plus z, this I will take and I am going to separate it from this and this. So y plus z minus x plus y upon BC minus AB, okay, which is equal to y plus z minus x minus y upon BC minus AB, which is equal to. Now, if you take this, what y plus z and this y, okay, what we will be getting is z minus x upon common b c minus a, which is equal to k. This will be my equation number 2. Now similarly, again by theorem of equal ratios, by theorem on equal ratios, similarly by theorem on equal ratios, what are we going to get? We are going to use the third one. In that we will take z plus x minus y. We will take z plus x and we are going to take y plus z and we are going to subtract this. So y plus z upon AC minus BC, which is equal to z plus x minus y plus y. This gives me minus y, minus into plus gives me minus z upon AC minus BC. So what will go here? Z, Z. What do I get? X minus y upon, what I can remove common over here? C. I get A minus B, which is equal to K. Equation number 3. So from equation number 1, 2 and 3, what do we get? From 1, 2 and 3, we get, what do we get? Look at our equations. Equation number 1, y minus z upon a b minus c, okay. So we get y minus z upon a b minus c, which is equal to, equation number 2 gave me z minus x upon b c minus a, which is equal to, what did equation number 3 give me? X minus y upon, what I have here? C a minus b. So we saw, we got this by the theorem on equal ratios. Now what we have is, if x upon 3x minus 5, 3x minus y minus z is equal to y upon 3y minus z minus x, which is equal to z upon 3z minus x minus y, and x plus y plus z is not equal to 0, then show that the value of each ratio is equal to 1. To show that each ratio is equal to 1, let us see what is given to us. Solution: x upon 3x minus y minus z is equal to y upon 3y minus z minus x is equal to z upon 3z minus x minus y. Let us use the theorem on equal ratios here. So, by theorem on equal ratios, which is equal to x plus y plus z upon what we have here, 3x minus y minus z plus 3y minus z minus x plus 3z minus x minus y, which is equal to, bring all x's and y together, x plus y plus z upon 3x minus x minus x minus y plus 3y minus y plus I am getting is minus z plus 3z, which is equal to x plus y plus z upon, from this 3 minus 2 gives me x plus y plus z. Now this ratio is equal to 1 when, since x plus y plus z not equal to 0, because this and this 1 1 1 gives me 1. Okay, thank you children. We will be continuing in our next session.